This is my OKUMA crown lathe. It's in excellent condition. It has the OSP 700L controller. I'll walk around it and then I'll show you the features. I'll actually do a little cutting with it. On this machine, I recently had the vac drive rebuilt, which cost me $3,000. There's the information of the lathe right here, if you can read it. So it has a brand new vac drive in the cabinet. That was $3,500. I've had the machine completely inspected twice. It's in great condition. I also replaced the controller battery. It's in great condition. It holds tolerances like crazy. There's absolutely no backlash in the ball screw. Here in the parameters, you can see the backlash compensation has not been messed with. This is what it's set at the factory. And I've actually talked to OKUMA about this machine several times, and it doesn't have, at least we can't find an hour meter on this machine. And as far as the year, it's a 90s. And that's pretty much all they can tell me about this. But I had someone say that the spindle sounded a little loud to them, but I called OKUMA, and when I had a tech out here, they inspected it. Everything's fine. They just said some of these are a little louder like that. This isn't loud by any means. I've had different OKUMA lathes in here and they've been way louder, and you know, there's no problem with it at all. So it's got a 10-place tool holder, or is it 12? Sorry, 12-place tool holder. Everything works inside of here. Jaws open and close, no problem. Tailstock comes in and out, no problem. You just have to set it to tailstock mode or chuck mode. I replaced the light in it. And so I'll show you how I get programs into it, and I'll actually run this part for you so that you can hear it, and then we'll measure it and we'll see what kind of tolerance we're holding here. So here's what I do with all of mine, is I design in Fusion 360 and export it. So let's measure that right there. So the diameter of that is 1.50 is what this piece is supposed to be. So if you see here, I got a facing operation. Then right here, I'm just bringing this 2-inch stock down to 1.5 inches. So this is what we'll do here. I'll export this to a USB stick, post-process it out. I'll put it in my USB stick here, which is already in there, but I'll go ahead and replace it. Eject that. I use these as a Titan DNC box. It runs right to the RS-232 port. You just plug your USB stick in there. Pulls up the program. Set it to send. So now we go into here in the edit. Go into PIP. Read, enter. It's going to say it's already in there, but I want to override it. Yes. And then you'll see it feeds right into the machine. And that's at 100% fed into the machine. Now go over to auto, program select, go to index. There's the program right there. Hit right again, part program, and there it is. So that's how easy it is to get programs from your computer into this controller. So we'll run this part here and we'll measure it. So you can see here right now, this is that's 2-inch stock. So we're trying to knock it down to 1.5, and we'll see how accurate it is. Just hit cycle start. And like I said, to me, the spindle isn't loud, but I've had somebody say it sounded a little loud, but maybe they were just trying to get a little money off the machine. But after that, I did have it inspected. The bearings are fine. This thing is fine. It holds tolerance like you'll see like crazy, and there's no problem. So it's gonna take a little bit to run this, maybe, I don't know, 5 or 6 minutes here, but I'll keep you on and so you can see the whole process. You see here, it's running fine. It's also, in the video, I think it sounds louder than in person. So the person that said it sounded louder was actually commenting on the video and didn't see this in person. So that's probably something to. But because here in person, it's not loud at all to me. So this first one is just a little light pass. The second one is a lot deeper. And this thing will cut, this is aluminum right here. It'll cut steel just like it does aluminum. It feels just like butter. So you can see here, it's a thicker cut. And I'm also not using coolant for this video, so you can see it's cutting it fine, nice and smooth. So I won't stop this video, I'll just let it run, so as you can see I'm not stopping it and starting it. You can see it actually run this part all the way through. See over here, it's just running through the code right here. It's kind of feeding it in there as it needs it. Again, the bearing's been checked by a tech. The whole machine's been gone through. I've had the vac drive rebuilt. That was $3,500. That's one thing that you don't have to worry about going out. I love this lathe. I would keep it, but I need something with live tooling so that I can do flats on my parts instead of bringing them over to the mill after this. And that's the only reason I'm getting rid of it. Other than that, this lathe is bulletproof. You won't find one for sale online that's been gone through like this, that they're actually showing you everything I'm showing you in the video. There's no hidden surprises with this machine. It is what it is. It's in great working condition. No problems whatsoever. So I think this is the last pass. Again, this is a real simple code that I just made up in the machine there, or on Fusion there. It took me a couple minutes, and there we go. So let's check it now with the micrometers. So again, this was 2 inches. We wanted this to be 1.50. Let's see what kind of tolerance we got. There you go. Boom. I don't know if you can see that. Doesn't get any better than that. 1.50. So here I'll zero it out again. Check it again. Boom, 1.50. Can't beat that tolerance.